Hello and welcome to the Buddy Podcast. I'm your host, Buddy Lindsay, and today we're going to talk about 3 programming languages for doing DIY electronics projects. Maybe you should consider learning 1 or 2 of them. But before that, if you haven't visited the website in a while, feel free to do so at buddiy.net. Sign up for that email newsletter so that you know when new content like this podcast comes out. We are also available on YouTube and Odyssey. Just search for Buddy, B-U-D-D-I-Y on each of those. Also available on Instagram at Buddy Lindsay Jr. and on Float at BUDDIY. And finally, this is a podcast. We are available on most major podcasting platforms. So just search for BUDDIY on there and you should be able to find me. So with all that out of the way, let's jump to the first segment of the week, and that is the quote of the week. And it is, "All wish to possess knowledge, but few, comparatively speaking, are willing to pay the price," by Juvenal. I thought this was a really good one because it's really interesting when learning new things, how tough it can be and how much work it takes to actually learn something and learn it well beyond just kind of the rudimentary information. And I know, like, once you get to a certain point, like, you're just like, you kind of hit this balance of like, is this too much? Is this too much work? Is this going to take too much time? And should I proceed? And a lot of people stop. A lot of people hit that dip and they just stop and they don't want to grind through to get to the other side to be able to truly understand. I think this comes into play when you come into programming and learning programming languages, if it's something you've never done before. Especially when you come at it from a different industry, or you've had no exposure to programming and you're all of a sudden like, maybe I should learn it, maybe I shouldn't, and you get into it and you're just like, oh, this is really, really hard and I don't know what I'm doing, and I'm just going to stop. And so I feel like, that this quote goes along well with learning how to program and learning programming languages. And I just want to encourage you, if you grind it out, get through that dip, get through that hard time, you're going to make it out the other side a lot better off. So with that, we're going to go to what's going on around here. Only got a couple things this week, and I spent a lot of time working this week, and so not really like too much. First up, spent about 15 minutes, worked on the farm's logo. I think it turned out okay. Still have a little more tweaking to it. It was just kind of a quick rough draft to send to a friend who's a designer, get his comments on it and some critiques to tweak. Made that with GIMP, so trying to walk the talk that I talked a while back of switching to free and open software, and really trying to support that community. So was excited about that. I did my first couple of things in GIMP, so yay. On my contracting project, I have officially moved to the last feature of the website that is a user-facing feature, and super excited to get working on that part because that's going to be a lot easier than the last feature that I just did. Made good progress on that, so I am chugging along. I feel like I am seeing the light at the end of the tunnel, and we are going to make it. And I cannot wait because I have so many projects to do. But hey, we are getting there. As soon as I get this part done and the next little part I need to do, I will tell you what this project is, how it can be useful to you, especially if you're a homesteader. So stay tuned for that. Really excited about this. I'm just ecstatic, but I got to keep grinding. I got to keep going. I got to keep moving. Even though my brain is like, you're gonna fail. I mean, I keep bringing this up, but it's still such a true thing, kind of from the entrepreneurial side point, starting new projects, even projects that you don't know. When you step out on that limb and do that thing that makes you uncomfortable, doing contracting job on the side is uncomfortable for me. It's not something I enjoy doing per se. I mean, I enjoy the work of the programming, but it's the expectation of getting, of completing the project, rounding it all out, and getting it delivered to a customer, that is not my employer. Like, it's not something I'm used to, so it has some uncomfortableness to it. And so you have that back of your brain that's like, you're gonna fail. And I bring this up every week, but I want to reiterate that when you do things that are uncomfortable, you do things that are entrepreneurial, you do things that step outside of where you are, you're gonna have that nagging thing in your head that is just going to constantly try to hold you back and pull you back, and you've got to fight it. I've been fighting it for the last few months, and I'm going to continue to fight it until I am successful. So yeah, anyway, I just wanted to bring that up on that. Like, still that fight, but you got to still persevere. Last two things is got a new tractor, another new tractor. We're on the third tractor now. We found out that the previous tractor that we bought was actually not the right size compared to the one that I have. And so my father-in-law decided, hey, he'll keep that one and he's actually going to try to get it running, and he's going to get rid of another tractor that he has and kind of downgrade a little bit because he doesn't like that other tractor and he likes this one better. So if he can get it running effectively, then he's going to just keep it and use that instead. And then we're going to take this new one that we bought, which we bought for a lot cheaper, and that's going to be the new parts tractor. There's actually a bunch of good parts on it that is going to work out really well for rebuilding the tractor that I have and providing parts for many years to come. And so we're really happy that we got that. It was like a 4-hour drive to get there. Fortunately, the guy had this heavy-duty skid steer, and he just kind of loaded it on the back of the trailer for us. I think we were there for 45 minutes total between waiting for him, getting it loaded, getting it strapped down, and talking a little bit, and then leaving. So that was a really, really fast pickup compared to the time that I got a high lift jack in my face. So yeah, and no trips to the ER, so that was even better. Yeah, so really excited about that. You know, that project's moving along. Father-in-law is going to check on the gas tank for that and see if we can actually move it over, because the gas tank on the current tractor has a bunch of sludge and crap in it. And so if the new tractor, you know, has a better gas tank, we'll just swap them and call it a day. Outside of that, the truck, actually I guess three things. The truck is still kind of in waiting. We did pull off the power steering pump and compare it to the original, and we did find that the manufacturer did make it 1/8 of an inch too thick, too big, and so that's why the pulley is off by roughly 1/8 of an inch, maybe a tiny bit more. My father-in-law was looking at it. He thinks we can go another 1/8 of an inch on pushing the pulley on, so we'll have to check on that. He's not 100% sure, so we will try. I just haven't had a chance to get over to do that, so the truck saga might finally be ending, I hope, because I think we've spent nearly $700 in just different things trying to get this fixed, and it has not been a fun time. And then finally, over the last couple of months, I've been doing Duolingo for my Japanese, you know, off and on. Usually one a little less than a day or something like that. And you know, I started thinking I enjoy doing Japanese. In all likelihood, learning Japanese is not going to have any substantial benefit to me in life going forward that I can tell. I mean, from a socioeconomic perspective, I'm not moving to Japan anytime soon. Probably never. I don't have anyone around here that speaks Japanese. I don't have any, you know, that I'm dealing with. Might not even visit Japan anytime in the next decade, or so. I don't know. It depends on, you know, with kids. Just like you just learning Japanese, like there's no financial or reason to learn it other than it's kind of interesting to learn. But there's also the sunk cost fallacy of like, hey, you've invested so much time and so much effort into learning this, you should finish learning it. You know, there's that concept in business: invested all this time and money, you should just keep going because you've invested all this time and money. And so I'm just curious, like, is it worth learning? Is it worth continuing? I mean, get outside the platitudes of, oh, you should learn a second language because it makes you smarter, blah, 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 all that bull crap. Like, get outside of that. Is it worth spending that time to learn it? Because I can get through the Duolingo stuff in probably a year with the pace that I'm going. Japanese to me is an easy language to learn once you get past some of the basics. It's more just a matter of memorizing the vocabulary and some of the kanji. And so, like, I can get there. I can get it to where I can do some basic conversations. But is it worth it? I mean, let's be honest. Is it worth doing that? Other than the fact, you know, I kind of like doing it. I have time invested in sunk cost fallacy. I mean, I have the sunk cost into it. The other side is it worth learning Spanish? I mean, that could have Spanish or Chinese. I mean, Spanish has the immediate economic benefit of people around here that speak Spanish. I know a couple of teachers that that do Spanish. I don't like the language per se. Like, it's just something about it. I just don't like the sound of the language. It's kind of like I like the sound of Chinese and Japanese a little better than Korean. Korean has a funky twang to it, to my ear. Spanish is the same way. I prefer, if we're going to go with that kind of language, I prefer the French language over Spanish as well. I took French in high school a little bit. Just something's funny about Spanish to me. I'm not the biggest fan of how it sounds, but that doesn't mean I wouldn't learn it. I don't want to. So from an economic perspective, though, Chinese might be a better language to learn because, let's face it, there's more Chinese, people. There's more Chinese than there are Americans. I mean, the other option is Hindi. I mean, India is an up-and-coming power. They have over 1 billion people there. There's some interesting things going on there. I like Bollywood movies. They're interesting. I mean, some of the movies they've created on the budgets that they have compared to the Hollywood budgets. I mean, you compare it, like, amazing work done by them. And the language is actually really interesting. I find it interesting the fluidness that they mix Hindi and English in some of the areas. I know that's a cultural thing. I don't want to get into the politics of that, and the same thing with Tamil and a couple of other languages in India. But mostly Hindi is the dominant language in India. And so it's like there's an option to learn as well. I don't know. I just kind of continue learning Japanese because I have learned Japanese, and I don't know whether it's worth it. So if you are in a position like that and you have gone through that analysis, what do you think on learning language? It's just something I'm not sure about, and I would like y'all's opinion. With all of that out of the way, that little rambling direction down into languages that is super interesting, let's talk about 3 more languages, and that is programming languages. The first thing up I want to hit is why learn to program. So I could talk about this topic for a long time. I taught how to program. I teach how to program. I do it as a living. It's very interesting and very fascinating. It is something that I truly do enjoy doing. So I could talk for a real long time on why you should learn how to program, and then all the little things that go around programming. The main reason that I think you should learn how to program is because I believe it is going to be a skill that is valuable to you in the future in life, in doing DIY. More and more stuff is becoming electronic. More and more software that we use is getting to be more advanced, and there are options to make things better based on programming, based on modifying scripts and other things like that. And so understanding how they work, understanding how to deal with them can make life a lot easier, especially if you want to get into some of the more advanced automation. Knowing how to program some of that stuff can make life a lot easier, and you can really set a few things up. Other sides to learning programming is you can automate. There's actually a really good book, a Python book called Automate the Boring Stuff. You can learn how to automate some of the things that you don't want to do. In this podcast, I have what I call paperwork, and I have part of it automated with little bitty scripts. They're like a few lines long, and they just create things for me that I don't have to worry about creating a new file every single time with this particular piece of information in it that does this particular thing. I have written a little script that creates all those things for me in less than a second, whereas by hand it would take me probably 4 minutes. But 4 minutes over the course of 100 podcasts, and now you're at 400 minutes, and so it can really like save yourself time, and a lot of other benefits on that. But I really think outside of the practicality of it, I also believe that it helps you organize your thoughts. It helps you to logically think through things and assess how to get things done. And I think it helps with project management skills and being able to define a set of work that needs to get done, work through these steps to get it done, and finally get out to the execution on the other side to see the result. Most projects around, your house, you do the same thing. I think it's another way to do that because especially in a virtual sense where you don't have a project that is fully formed and you see the entire result as it's being built in physically in person. The virtual side to that, you need to be a little better about your project management skills, and I think programming really helps to develop that. Plus, it can be a lot of fun. I think you should learn it because it can be a lot of fun. That dopamine rush when you get that thing to work is just amazing. The other night, whenever I got a piece of my contracting job working, I was ready to get up and dance because of what I got working and how it was working, how well it worked, how simple it was, and it was super amazing. So I think those are reasons to learn how to program outside of the practical benefits of all the things that you can do with it. So a couple final points on this. Programming is not about just sitting down and typing code for hours and hours a day. It is about problem solving. It is about having a vision of what you want to happen, writing some text in a file to accomplish that goal. You are literally turning words into something that does something else and saves you time. To me, that's one of the fascinating parts about programming. Another thing is people are really concerned that you have to know all this advanced math. You don't. You don't need to know math hardly at all past 8th grade math at most. And basically, if you know algebra, you can program. Unless you're going to get into stuff that requires a bunch of math, and usually all of that you can find by Googling and figure it out or ask somebody for help. You don't need to know much math. The reason that a lot of curriculums, I have my computer science degree, and so I know kind of where this comes from. The reason you take a lot of math classes in college is not because you need to know all this math to do programming. Very, very few programming professions require all that math, and they're always very specific to the job. And most of that you would learn on the job and know how to plug it in there. Now, the reason you learn a lot of the programming is because you need to learn logic and how to step through a process and how to create a process to do something. Because programming is logic. Programming is A to B to C, back to A to B to C, back to A to B to C, then to D. It's that kind of thing. And I just took you through a flow control situation there. And so it's all about just thinking things through and logically getting from point A to point B and keeping track of your steps along the way. So with that out of the way, what are some of the things that you should probably learn to be able to program as you're learning how to program? That was a very confusing statement, I'm sure. It's more like, if you were to learn to program today, what are the few things that I would recommend that you learn and understand what they are as kind of the beginning of programming? There are some crazy concepts like dependency injection and polymorphism and encapsulation and all these other things, and I can throw out probably 20 more jargony words that could mean really cool and interesting things inside of programming. Don't worry about it. It doesn't matter to you right now. It's probably not going to matter to you for a very, very long time. And if you get to the point that you're writing that advanced of programming or that advanced of programs, then you don't need this podcast anymore. So don't worry about a whole bunch of the jargon. I'm going to distill it down to about 5 things that I really recommend that you do to learn programming and really understand. The first one is flow control. Flow control sounds complicated, but it's really simple. I actually took you through a flow control. You go to A to B to C, to A to B to C, to A to B to C to D. I took you through a loop. You went through a loop right there. And then once your loop was done, you moved on to the next step. So your first flow control is a loop. The other flow control is if this, then that. If else. If I run inside, then I am in the house. If I open the door, then the door is open. Go a little bit further. If I open the door, then the alarm goes off. If the alarm is set to go off. There you go. So here, let's break it down. If I open the door and the alarm is set to go off, then the alarm will go off. So that's an if-then statement. I just took you through 2 flow control statements. There's a couple of more, but that's really about it. I mean, the idea of like just what happens when you execute these things, when you do these things, what happens. The next thing is variables. If you know algebra, variables is super easy to understand. You have x plus 2 equals 3. You separate the x, so you do subtract 2 from each side. So x equals 3 minus 2 equals 1. So x equals 1. So now you take that 1, you pop it back into 1 plus 2 equals 3. So you have x was that variable, x was that unknown, and you went through things to set x to 1. A variable is just a placeholder that you say, hey, with this thing here, this x can change over time, and so I just want to, when I reference this information, I just want to use this because it could keep changing. And so like that's really all a variable is. It's a little, it's a little more advanced than algebra, but it's basically the same thing. Once you do it a couple of times in programming, you're like, oh, I get what's going on there. And there are things that could make it complicated, but I would not worry about those in the beginning. Then there are function and subroutines. First time I heard about subroutines was in Star Trek, and I'm like, woo, what's all of that? And I'm like, now that I know how to program, I hate when I hear subroutines in Star Trek, because it's like, I don't think that's what you're really doing. I don't think you're executing. Okay, kind of you're executing a subroutine, but you're not really executing a subroutine. The subroutine is a function. It is a little piece of code that does the same thing every single time, and you might want to break out all of your code instead of having this one large chunk of code that is 100 lines long, and you have this same subroutine, the same little code that's repeated 2 or 3 times in there. You just break it out into this little thing over here called a function or a subroutine. And then anytime in this 100 lines of code, now you've just shrank your 100 lines to, let's say, 75 lines. And every time you need that, you just say, hey, call this over here. Just call this over here. Oh, call this over here. And it helps you organize your code a little better. Plus you can get them really descriptive names, which is what I do, so that you actually understand what's going on over there, so you have good documentation of your code. So that's really the third thing. So the first thing was flow control, your loops and your ifs. Second thing is your variables. So your algebras, your x equals y, your x equals 1, whatever. And then you have your functions or subroutines. That is just code organization. It's really all there is to it. There are some intricacies to it, but really it's just how to help you organize your code so that you don't go crazy trying to change code later. The next thing is data structures. Dun, dun, dun. Many classes exist on data structures. Ignore them all. There are tons of data structures. It sounds super complicated. It can get super complicated. But for the most part, the data structures that you need to be concerned about are lists. Do you know how to make a list? You write a thing down, and then you write another thing down, and then you write another thing down, and now you have a list of things to do. That's the main data structure that you need to understand in programming. You make a list of things, you make a list of numbers, you make a list of tasks, you make a list of all kinds of things. And then you loop that flow control, you loop over them. Look at this thing. Oh, it's a 1. Okay, cool. I'm going to save 1 to this variable. You go to the next line. Oh, I have a 2. I'm going to save it. I'm going to now add it to this variable that I have over here that I set to 1, and now I have 3. And then you go to the next one and add it, and go to the next one and add it, and you go to the next one and add it. All the while you've only used that one variable, and you've looped through a data structure, a list of things, and now you have added up all of the things in that list and you have the final result. All kinds of ways that this could be useful. Let's say that you need to get the average of a bunch of different data. Now you have 20 things. Think about this in your grades. you have, and when you were in school, you have 20 different grades on 20, you have on 20 different papers. You would add them all up. You have your, 90, 90, 90, 95, 95, 95, 95, 100, 100, 100, 100, 20 times. And, now you add all of those things up in that loop. Then you're like, okay, now I have that total. It's an x. X equals the sum of all of those. And now I'm going to divide it by the length of that list, which is 20. And so now hey, the average grade for all of these was 96, or whatever. So now you have done something that is, So in the time that we've been talking, we just literally programmed something. From there, it's just a matter of learning the syntax to be able to write everything down. Hopefully it made sense. Programming is not that hard to get started at. It's when you start doing some of the really advanced stuff that it can get really, really complicated. But for the most part, from my progression to learning, that advanced stuff didn't even make enough sense to try until I got to that stage. I think a perfect example is when I was learning a new web framework. I was doing all these things that were basic, just very basic, rudimentary things. I didn't understand a lot about the framework, and I was just building more and more and more and more. And then one day I was like, I need to do, I have this thing right here, and I need to show up I need to use everything. I need to use this in all these different places over here. It's like, and I'm like, wait, I think I read about this thing that you can do. Let me try that real fast. And so I went and tried it, boom, and it worked. It's like, it was one of those things like when the student is ready to learn, the teacher will appear. Same thing. It's like, once I got to a point where I was ready to understand what was going to happen, that new concept, that more advanced concept made sense all of a sudden. In a lot of cases, a lot of that stuff is not going to make sense until you're ready to understand it, until you're knowledge of programming is there. So don't worry about learning all the advanced stuff, because the final thing that I wanted to get to on learning how to program is just write lots of code, do lots of examples, practice, 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 do some of the dumbest things you've ever done in your life, programming wise. Make little bitty, text-based games that, practice if this, then that, get the, automate the boring stuff for Python, and do some of the stuff to automate some of the stuff in your life. Look at some of the things that there's a fun thing that exists in the programming world where a guy loved to automate stuff. He automated stuff so much that when he left a company he was working for, they started looking through his computer as to what was there in case they needed something. And they found a bunch of scripts, and this guy had this code running where if he hadn't logged off after like 6 o'clock or something, it would go to a text file, look in there, and find and it would grab one of 5 canned messages. It would then send a text message to his wife saying, "Hey, I'm going to be late. This is the reason I'm late. I'll see you home later." Or something, because it could be all kinds of different reasons, but mostly like he was just working late and he was going to be home later, and it just automatically did it, and he didn't have to worry about trying to remember to text his wife that he was going to be late. Another one is he figured out that his coffee pot was hooked up to the network, and he figured out how to talk to it, and when he would get to the office, he would run this little program, and he had it figured out that it took something like 18 seconds for him to get from his desk to his coffee to the thing. And so he would hit the button and he would start it, and by the time he got there, it would be a fresh cup of coffee in order for him to have the freshest coffee there. And he was usually the first one in, I guess, so he would start up the coffee. Anyway, just stuff like that, dumb little things that just make your life easier. I recommend you try those. Go look at other programs that other people do. One thing that I like to program is just reminders of stuff. Just like it just pops up little reminders here and there for me. Just things like that. I recommend just practicing, because it can be a lot of fun, And then when you're ready to get to the more practical stuff, it'll more readily be available, and you have understanding to do it. So on that note, this is really running long, and I am only through my second section of 7. So what I'm going to try to do is I'm going to speed up a little bit. Like I said, I could talk about this stuff for a really long time because it's so much fun. But I wanted to get through some foundation of what and why and I really think you do. So I want to get to the 3 programming languages that I think you would benefit from eventually learning. Choose one. I'm going to give my recommendation at the end of which one I think you should learn. But I want to talk about 3 ones that I see as the key primary languages that exist in the DIY community. And when I say the DIY community, I mean the expanse of most programming, but I want to specifically go towards electronics development stuff and automation on a computer. And those 3 are C, Python, and JavaScript. And I want to do a quick summation of the history of those. C was developed a long time ago in the 70s, arguably the late 60s, but mainly in the 70s. And so when you have a computer, you have the processor and the RAM and all that other stuff. Well, it used to be you would program something called assembly, and assembly was designed specifically for, or would have specifics to that particular type of processor. So right now you might hear about the ARM processor that's in phones and the Intel, the x86 processor that is in most of your computers. Well, you would have assembly, this assembly language, quote unquote. I mean, this is the lowest level of programming you can do on a computer. And it would be dependent what you do based on whether you had an ARM processor or an x86 processor. Like, it literally mattered which processor you had depending on the code that you write. So what they did is were like we wanted something a little more expressive, something is a little more approachable, but something else underneath that automates handling what processor you're using. And so they came up with C. And C basically is a defined set of syntax, of words to use, of whatever, to be able to compile it down to that machine language, that assembly language in a sense, so that you still have that raw power that's available down there, but it's a little more approachable, and you can go from computer architecture to computer architecture and still write your software. That is a very basic history of C. It is very, very fast and basically meant for raw power. In a sense, if you need raw power, you go with C most of the time. Occasionally you do assembly, but that's very rare. So, or if you don't have a lot of memory that you have available, but that's getting more application specific. But C is kind of there, and a lot of electronics have C available to use, and so learning C, it is hard, it is complicated, but it's not impossible. It is where I started to learn programming whenever I started learning programming. The next step, let's say 100 steps up from that in simplicity, you have JavaScript and Python. I think Python's easier, but it has its set of utilities, and JavaScript has its set of utilities. JavaScript is what's called a C-based language, and so it has a lot of structure around C, but is definitely not C. And it just has a few things. It just has a bunch of stuff that feels like C in it. And it has its own way of executing code versus Python, but they are a lot more approachable in learning and reading and getting started with. JavaScript actually started out on the web in your browser, and then I think, like 15, 20 years ago? No, not 20. 15 years ago? Yeah, that sounds more about right. Google came out with what's called the V8 engine and allowed JavaScript to be not just in the browser anymore. And so it's become a very, very popular programming language because of because of how it works. I want to go into the specifics, but I'm not going to because you're not going to know what I mean. And then Python has been around for like 30 years or more, 40 maybe, probably 30. And it was, I'm not going to say designed from day one to be super approachable and super easy, but pretty much was. It is slower than C. JavaScript is slower than C. There are some things along the way to make it fairly fast. Most of the times with the speed of most computers and most processors, that speed does not matter. It's negligible to what you're doing. So that's a little bit of the history of those three languages, C, JavaScript, and Python. I want to get into kind of the three platforms that are potentially used for doing electronics projects. First one, and one of the, if not the most popular, is the Arduino. It's synonymous with doing electronics projects. Most of the time you're going to deal with C or a C variant. With that, they have an IDE. They make it super simple to get started. So if you can learn the basics of programming, you can start with Arduino and start with C, and you don't have to deal with a lot of the more advanced features of C to get your program going. There could be some really complicated stuff in C that with Arduino and their like custom way they do stuff, you just don't have to deal with and worry about. And then as you grow and as you get more advanced with C, you can grow and use more advanced features of C. And then I think in my DIY projects that I have, specifically the dust detector that I still need to finish someday. This project is killing me. It uses the ATmega 328, which is the microcontroller chip that is on the Arduino, and I'm using C with that, using Arduino's custom little C thingy to write that, so you can burn it directly to a chip and use it directly. Really cool project, really cool way to do things, but C is generally used with the Arduino. The next little board and controller is the Raspberry Pi. The Raspberry Pi is super popular because it's basically a computer that is smaller. I mean, it's got an ARM processor, and lots of stuff now works with ARM processors. It's got a full Linux operating system on there. It's got GPIO ports on there to be able to connect peripherals to. It's got HDMI, it's got 4K, depending on which one you get. It's got lots of RAM comparatively. I mean, it can do everything. It can run a full windowed desktop for you if you need it to with Linux. So there's a lot of power there, and that means you can run Python, Node, C, and about 100 other languages that are available on there. But you can definitely do all three of those, and you can mix and match even depending on what you're trying to get done. So super powerful chip, lots of things you can do with it, and it's actually a really approachable board to get used to. And then the third one that I see the most is the ESP32, and it is another type of microcontroller that exists, and a lot of people use Python. It can use C, Python, and Node.js depending on what environment that you put on it. A lot of people do MicroPython, which is a Python variant. It is Python, but they just don't have some of the features of Python in there. Most of the time, it's not going to matter. And so so those are kind of the three platforms that you can do programming on, and some of the languages that go with them. And yeah, so it's kind of like depending on what you need to do. I have an ESP32 because it's built-in Wi-Fi module that I don't need to attach to it for some temperature gauges that I want to do. I'm using the ATmega 328 with the doing a custom build for the dust detector because I want to. I could easily do it with an Arduino Uno and call it a day. Or I could use the Raspberry Pi just as well to do some of the same stuff. I just wanted to use the Arduino and ATmega 328. You might use that to do more kind of lower level controlling of stuff, and you have power consumption issues. So a couple of the things that I want to deal with, I don't want it to be running all the time. I want it to start up and turn off. Start up, be efficiently run, and then kind of turn itself off, suspend itself. for a set amount of time. The Raspberry Pi is not going to necessarily be good for that. More the ESP32 and the Arduino are going to be better for that. So it kind of depends on what your needs are for the project. If you're just going to have it run all the time, then the Raspberry Pi might not be a bad idea, except for the cost. You can get an Arduino Uno, like a small little one. I can't think of what it is anyway, for like $2. And I have a microcontroller with a bunch of different things connected to it, or you can go even cheaper than that and you can build your own board and other stuff, but you have a lot more complexity available in that as well. So lots of different things that you can do. I just kind of wanted to bring up some of the platforms that you deal with those. And then finally, let's jump onto some of the projects that you can do. Just a few, around the homestead. I mean, you can do temperature monitors everywhere. That's something that I really want to do. My dust detector in the shop that I want to do. You can do a thing that opens up your coop door and closes it based on what time of the day it is. You can even connect it to Wi-Fi so you can control it from your phone. You can control lighting in all different locations. You can do it in a desk. You can do it around your house. You can do all kind of different things you want to do with it. I mean, just the things you can do with electronics are pretty much limitless. They just get more complex over time. And some of the stuff that I want to do on the homestead should make for interesting projects in the future. But I wanted to mention, programming languages because I feel like when some people want to get started doing DIY and doing electronics, it's like, where do I start? Like, what do I do? And so I wanted to bring an overview of some of the stuff. I can go into a lot more detail on a lot of this. I had to really fight myself to not do that now. But I wanted to bring an overview of kind of some of the higher level things. I wanted to kind of all the options that are available. I wanted to just distill down into just a few so you don't have analysis paralysis. So let's just recap, and then I'm going to give my recommendations of what I recommend that you do to get started learning and to give you a starting point. So recap, there's C, there's Node.js, C and JavaScript. Node.js is the underlying runtime of JavaScript, but C, JavaScript, and Python. Those are the three languages that I recommend that you learn one of them. My recommendation based on that is Python. It's easy and approachable and gets you started in it. And once you learn one programming language, once you learn all the concepts that I went over in programming, as you start, you can muddle through a lot of other code and get a gist of what they're doing. You may not be able to write that code for that particular language, but most of the time, you will be able to read what it's doing and understand what it's doing to be able to replicate in your code. And so it kind of really gives you a lot of extra stuff that you can do. Python, again, is easily approachable and solves a lot of things for you that you don't need to necessarily worry about. Plus, it can grow with you. Again, I use Python every day, and I am a professional software developer. So it can be used at the lowest level of knowledge at the very, very beginning, all the way up to really advanced stuff. So my recommendation is to start with Python. From a board to actually start with, I recommend the Raspberry Pi. I like the Arduino. I like the ESP32. But from a getting started perspective, to be able to connect to a Raspberry Pi and run commands on a command line and practice and be able to learn how to program in Python on that thing, and then be able to connect electronic devices to that Raspberry Pi and be able to do stuff against those on the same machine. Like, I don't have to worry about, like, how do I get it, burn it onto the chip, and all that other stuff, and it might not necessarily work, and you got the serial port connection and all of that. I can do that. I can do Python. I can do Node. I can do C on the Raspberry Pi as well. All different things that I can do, and all a great place to get started. So I recommend starting with the Raspberry Pi. So again, this was just an overview. I didn't want to go into too much detail. If that's something that you would like, if you'd like me to go into more detail on any of these topics, shoot me an email and let me know. buddiy.net, hit that contact form. Just want to do an overview. Hopefully that kind of gets you a little further, and maybe if you've been contemplating going down this route, it gives you a place to start. Again, if you want to know more information, let me know. I'm going to skip the failure of the week because I went a little too long on this overall. And I just want to let you all go. Thank you for watching. Thank you for listening. Happy DIYing, and we'll see you next time.